Imagine a world where energy is limitless, clean, and available everywhere. A world where power plants don't rely on the whims of the sun or the wind. A world where the energy beneath our feet could power civilization for millennia. That world isn't science fiction, it's closer than you think. Beneath the Earth's surface lies a vault of almost unimaginable energy. Scientists estimate that just the top 20,000 feet of the Earth's crust holds over 2,000 zettajoules of thermal energy. To put that in perspective, that's enough to power the entire globe for more than 15,000 years. Yet despite this staggering potential, geothermal energy has remained largely untapped. In the US, it accounts for less than 0.5% of total electricity generation. So why aren't we using this incredible resource? The answer lies in geology and the limitations of traditional geothermal technology. For over a century, geothermal energy has been confined to rare hotspots like Iceland or California. These locations have the perfect trifecta: heat, water, and permeable rock. Without all three, traditional geothermal plants simply can't function. That's why only about 2% of the Earth's surface has been viable for geothermal energy until now. A startup called Sage Geosystems claims to have cracked the code. Their breakthrough could unlock geothermal energy across 50 to 60% of the planet's surface. How? By rethinking the entire approach to tapping the Earth's heat. Instead of searching for natural hot springs, Sage drills deep into hot, dry rock, the kind found almost everywhere. Then, they use a technique called gravity fracking to create fractures in the rock. This isn't the controversial chemical fracking you might be thinking of. Sage uses only water and crushed rock to create a single, large fracture network underground. For smaller projects, they can even repurpose abandoned oil and gas wells. This cuts costs by up to 25% and reduces environmental impact. For larger utility-scale projects, Sage borrows a strategy from the Texas oil fields' multi-well pads. A single walking rig can drill 18 to 20 wells in one location. Fluid is pumped down one well, heated by the rock, and returned through another. A single pad can generate 50 megawatts, enough to power 35,000 homes. Their target cost? Just 6.5 cents per kilowatt hour. But extracting heat is only half the battle. Turning that heat into electricity efficiently is where Sage's innovation truly shines. They've developed a supercritical CO2 turbine, a marvel of engineering. Unlike traditional steam turbines or organic Rankine cycle systems, this turbine is compact and ultra-efficient. The turbine wheel is just 7 inches in diameter and must be 3D printed for precision. This design extracts more electricity from the same amount of heat. But Sage's vision goes beyond just power generation. Their system can also store energy massively and affordably. When solar or wind power is abundant, excess electricity pumps water into underground fractures. The pressure stores energy like a giant subterranean battery. When power is needed, the water is released, driving the turbine as it returns to the surface. This Earth store system can store energy for 2 to 18 hours, far longer than lithium-ion batteries. And the cost? A mere 4 cents per kilowatt hour. No rare minerals, no toxic chemicals, just water and steel. Of course, any discussion of fracking raises concerns. Earthquakes, environmental impact, these are valid questions. Sage's gravity fracking avoids natural fractures, drastically reducing seismic risks. Their process uses only water and crushed rock, eliminating the need for harmful chemicals. And unlike fossil fuels, geothermal produces near-zero emissions once operational. But what about cooling the Earth's core? Could we accidentally turn our planet into a cold, lifeless rock? The short answer, no. Funding, grid connections, supply chain bottlenecks, these hurdles are real, but the potential is undeniable. If the oil and gas industry shifted its expertise to geothermal, we could supply 80% of global electricity by 2050. We're at the same inflection point solar was 15 years ago. Back then, few believed solar could scale. Today, it's a cornerstone of renewable energy. Geothermal could follow the same trajectory if we seize the opportunity. The biggest advantage of fossil fuels has always been controllability. Grid operators can ramp gas plants up or down as needed. Wind and solar, for all their benefits, can't match that flexibility. But geothermal can. It's a 24/7 power source that can be built almost anywhere. And in an era of exploding AI energy demands, that reliability is priceless. Every ChatGPT query, every data center, these require constant, predictable power. Geothermal could be the answer. The question is, will we embrace it in time? The race for clean energy is heating up literally. As AI, electric vehicles, and industrial growth drive demand, renewables must scale faster than ever. Solar and wind have made incredible strides, but they can't do it alone. Geothermal's time has come. Sage Geosystems isn't the only player in this space, but their approach is uniquely pragmatic. They're not just geothermal idealists, they're drilling experts from the oil and gas industry. This gives them a critical edge, real-world experience in scaling energy projects. Their pressure geothermal system leverages existing oilfield technology, making adoption easier. Walking rigs, multi-well pads, fracture networks, these are proven concepts just applied differently. Even their energy storage solution is elegantly simple. Pump water underground when power is cheap, release it when demand peaks. No exotic materials, no complex chemistry, just physics and engineering. Compare that to lithium-ion batteries, which rely on finite resources like cobalt and lithium, or hydrogen, which requires massive infrastructure investments. Geothermal storage could be the missing piece in the renewable puzzle. But let's talk about risks. Every energy technology has trade-offs, and geothermal is no exception. Earthquakes are the most cited concern, but Sage's method minimizes this risk. By avoiding natural fault lines, their gravity fracking doesn't lubricate existing fractures. And because they use dense, water-based fluids, the pressure is more controlled. Still, monitoring and regulation will be crucial as this technology scales. Then there's the question of water usage. Geothermal systems need water, but so do coal, nuclear, and even solar plants. The difference? Geothermal's water is recycled in a closed loop. Unlike fossil fuels, it doesn't pollute or consume water irreversibly, and in drought-prone areas, treated wastewater or brine could be used instead. What about land use? A geothermal plant occupies far less space than a solar farm or wind park. Much of the infrastructure is underground, leaving the surface free for agriculture or conservation. For countries with limited land, this is a game changer. Now, let's address the elephant in the room: cost. Historically, geothermal's high upfront drilling expenses scared investors. Sage's innovations are changing that calculus. Repurposing old wells cuts costs significantly. Standardized drilling techniques borrowed from oil fields bring economies of scale, and their supercritical CO2 turbine boosts efficiency, improving returns. At 6.5 cents per kilowatt hour, geothermal is becoming competitive with natural gas. Add storage capabilities and the value proposition gets even stronger. But technology alone isn't enough. Policy and public support are equally important. Governments must streamline permitting for geothermal projects. Grid operators need to incentivize baseload renewables, not just intermittent ones. And the public must demand cleaner alternatives to fossil fuels. The good news? Momentum is building. Tech giants like Google and Microsoft are investing in next-gen geothermal. They need 24/7 clean power for data centers, and wind and solar alone won't cut it. Even oil majors are dipping their toes in, seeing geothermal as a future revenue stream. This cross-industry collaboration is exactly what's needed to accelerate progress. So what's next for Sage Geosystems? Pilot projects, scalability tests, and real-world validation. If their technology performs as promised, commercialization could happen within 5 to 10 years. That's not far off, considering how long it took solar to go from lab to grid. And the implications are profound. Imagine remote communities powered by local geothermal plants, industrial hubs running on constant, clean energy, entire cities unshackled from fossil fuels. This isn't just about electricity, it's about energy independence. Countries without oil reserves could tap their own geothermal wealth. Regions plagued by blackouts could have reliable power day and night. The geopolitical shifts alone would be monumental. Of course, challenges remain. Not every location will have ideal geology. Drilling deep enough will require ongoing innovation, and competing technologies like advanced nuclear will also vie for dominance. But geothermal's advantages are hard to ignore. It's renewable, resilient, and ready to scale. The Earth's heat isn't going away. The question is whether we'll harness it wisely. As Cindy from Sage put it, we're where solar was 15 years ago. Back then, skeptics dismissed it as a niche solution. Today, it's a global powerhouse. Geothermal could be next if we dare to dig deeper. So, what do you think? Could this be the energy breakthrough we've been waiting for? Or will challenges derail its potential? One thing's for sure, the future of energy is beneath our feet, and it's time to start digging.